Hi, this question is about refraction of a sound wave when it travels from hot air and it goes into another medium which have a different density and different temperature, that is cold air. Okay. Now we are given the path of the sound when it refracts from hot air to cold air, and we are being asked about the frequency and the wavelength. So I will show you the different diagrams. The ray diagram is already shown us in a question, but I will show you how the wave changes. Okay. And also give an example. Will you give an example that what happens when the sound enters in a water or the glass? So let's start. So this is a path of the sound when it go from the hot air to the cold air. Now, is this sound bending towards normal or away from normal? And what is the meaning of that? That what happens when sound bends away or towards? So for this, I need to show you the normal line, the vertical line to the point where the sound is incident. And for this purpose, I am going to show you this dotted line, which is made at a 90 degrees. And what we see that this sound is clearly bending towards normal. Okay. Now this is the angle of incidence and this is the angle of refraction. So angle of refraction is less than angle of incidence. Now, what does it mean when the sound bends towards normal or away from the normal? So let's take a practical example. When sound travels through air, the speed of the sound in air is 340 to 350 meter per second, although it depends on the temperature. But when the same sound, same longitudinal wave enters into the glass, its speed is more than 5000 meter per second. So it means that the sound speed increases. So this is a diagram of a sound when it go from the air to the glass. So as soon as it incident at that point, it refracts away from the normal and notice a difference. Different its wavelength. So first of all, this is the ray of the sound, means the line diagram. So do you notice that the wavelength of the sound has been increased? So it means that the wavelength always increases whenever the speed increases. So it means that the speed and the wavelength are directly proportional. So if the speed and the wavelength are directly proportional, it means that their ratio, which is equals to frequency, it never changes during the refraction because the ratio remains constant. So this thing, if you apply this concept to this diagram, so just imagine if now this is a sound which is going to the other medium and right now it is hit at that point. So we are given the path of this sound. So at this point we must draw the compressed sound waves. Why? Because its speed has decreased. So do you notice the wavelength has decreased? So it means that the wavelength decreases. And why wavelength decreases? Because it bends towards normal. And why wavelength increases in that example, in the practical example, because it bends away from the normal. So I told you this and I have written as well that sound bend towards normal, that's why the speed decreases and the wavelength decreases. So but what about the frequency will remain unchanged. So the right answer must be option B, frequency is unchanged and the wavelength decreases.